For lesson 8, we're going to continue our work with coordinate proofs and quadrilaterals. But we're going to start off with a quick question here about rhombus. A rhombus has diagonals of length 16 inches and 30 inches. Determine the perimeter of the rhombus. So this is a question that's shown up on the regions a bunch of times. So if we quickly just kind of sketch ourselves a rhombus, there's one thing we need to remember. If the diagonals are 16 and 30, well, carryover property from parallelograms is that the diagonals bisect each other. So it'd be 8 and 8, and then 15 and 15. And then a property that goes with rhombus is that our diagonals are perpendicular, which form a right angle. Now we have ourselves 4 right triangles within this rhombus. We can do Pythagorean theorem to solve for our missing sides. So A is going to be 8, B is going to be 15. Both of those are squared equals C squared, or actually I labeled it in my picture as X, so it will be X squared. 8 squared is 64, 15 squared is 225. 64 plus 225 is 289. Square root both sides, and you get 17. So one side of our rhombus is 17. If we multiply that by 4, we will get a perimeter of 68 inches. All right. So you got to remember a couple properties. One, carryover from parallelograms. One, specific to rhombus. As we get back into our proofs here, the first one says triangle ABC has those vertices. Side AB has a midpoint of D, and side BC has a midpoint of E, and side AC has a midpoint of F. So basically, this triangle has a midpoint labeled on all 3 of its sides. And then we want to prove quadrilateral ADEF is a parallelogram, but not a rhombus. All right, first things first, let's graph it. So A is -6, 1, 2, 3, 4, 5, 6, -2. So there's A. B is 2, 8. And C is 6, 1, 2, 3, 4, 5, 6, -2. Okay, so now this is a fairly big triangle, so make sure you use some sort of ruler or straight edge, something to get yourself an actual accurate triangle. Now it talks about how side AB, how all 3 sides have a midpoint. So before we do anything, if you notice, what they want us to prove, ADEF, involves all 3 of those midpoints. So we need to find them first. The first one I'm going to find is AC, because it's a horizontal line, so that's easiest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if it's 12 all the way across, we count 1, 2, 3, 4, 5, 6. And the midpoint of AC is going to be point F. So if we do the midpoint of AB now, we are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll be up 10 over 1, 2, 3, 4, 5, 6, 7, 8. So remember, if we want to find our midpoint, we cut that in half. So we'll be up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So 5 and 4, and that's going to be point D. And then for B and C, we are 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, actually, I didn't go over far enough here. So I actually counted correctly, but just didn't draw my line enough. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and -10. So half of that would be over 2, and down 1, 2, 3, 4, 5. So that is going to be point E. All right. So now obviously if you want to prove this is a parallelogram, we're probably going to want to connect all those missing sides. Okay, so if we do that, I connected D to E, I connected E to F, and the other 2 were already connected. All right, So what I'm going to do is I'm just going to highlight to make sure we're all clear on exactly what we are working with right here. So we're trying to prove that ADEF, that quadrilateral, is a parallelogram, but not a rhombus. Okay, so we should know by now probably the easiest way to prove that something is a rhombus, something is a parallelogram, is to do our slopes. All right. So what I'd like everybody to do is I'd like everybody to find the slope of all four of those sides. So pause the video for a second, and when you're ready, then you can play it again. So for AD, you can see we actually already have it for our midpoint counting. It was up 5/4. For DE, it was up or down 0 over 1, 2, 3, 4, 5, 6. So 0 over 6, well, 0 over anything is 0. For EF, we are up 1, 2, 3, 4, 5 over 1, 2, 3, 4. And then for AF, same thing. It is up or down 0, and then over 1, 2, 3, 4, 5, 6. So we are 0 over 6, which is 0. So if you can see here, we have our parallelogram because we have both sets of opposite sides congruent. So ADEF is a parallelogram because both sets of opposite sides are parallel. All right, remember that happened because they had the same slope. All right, so now we have taken care of that parallelogram piece, but the next part is we want to prove that it is not a rhombus. Okay, now in order to prove that it's not a rhombus, we have to prove that one of the specific rhombus properties is not true. Now, the one that people remember the most is a rhombus has four sides, or four congruent sides. So what they do is they pick two sides that are next to each other, they find the distance, and then they show that they're not the same. You could also take one of the other properties, such as the diagonals are perpendicular, so you could find the slope of DF and the slope of AE, and show that they are not negative reciprocals of each other. I'm going to take the one that is probably just most used, just so that it stays a little consistent for everybody. So I'm going to take sides, so for my distance, I'm going to take sides AD and AF. Now AF is nice and easy. Horizontal lines, you just have to count the boxes. All right, so AF has a length of 6, and that's just counting that piece. For AD, we're actually going to have to do the distance formula. Now you're probably going to want to just quickly jot down the points. So A was -6, -2, and D we found to be -1, -2, and then 1, 2, 3. So -2, 3. So our formula reads -2 minus -6 squared plus 3 minus -2 squared. All right. Again, we're just going to throw that whole thing into our calculator here. So we're -2 minus -6 squared plus, and then we were 3 minus -2. 3 minus -2 squared. That gives us 41, square root 41. Okay. Now remember, we don't have to simplify that. We don't care. We just need to know that square root of 41 is not 6. So ADEF is not a rhombus because all sides are not congruent. Okay, so once you prove that there are two sides that are not congruent, you have yourself you don't have yourself a rhombus, and it just has to stay a parallelogram. Okay, so a lot of stuff in that piece because of the midpoints. Then we were doing parallelogram, not a rhombus. But you can see if you just kind of work through the problem, stay patient, it's really not that bad. In example 2, the vertices of quadrilateral PLUS are blah blah. Prove quadrilateral PLUS is a rhombus. So first things first, we're going to graph everything. So negative 1, 2, 3, 4, 5. 1, 2, 3. So there's P. Negative 4, 7 is L. 0, 8 is U. And negative 1, 1, 2, 3, 4 is S. All right. So, I mean, just by looking at this definitely looks like a rhombus, but we want to make sure that we prove it correctly using our coordinate geometry stuff. Now, if you notice, there is a follow-up question on the bottom here. Explain why quadrilateral PLUS is not a square using coordinate geometry. And actually, I'm going to slide this up. I don't know why this is so far down here. So, we'll get to that in a couple minutes after we finish this. Now, to prove it's a rhombus, two ways. One, we could do exactly what we just did in the last problem. We could prove it's a parallelogram and then take two sides that were next to each other and do the distance. But in this case, we would find out that they are the same. Or, if you want to prove it's a rhombus, you just do the distance formula for all four sides to show that all four of them have the same distance. So it's kind of up to you. If you do all four distance, you only have to write one sentence. If you do what we did in the previous problem, you have to write two sentences. So I'm going to choose to do, I think, all the distance formulas here. So PL, LU, US, and PS. All right. So everybody pause the video for a second and take a minute to do the distance formula for all these problems. So as we do PL here, will be negative 4 minus negative 5 squared plus 7 minus 3 squared. If we put that all into our calculator, we are negative 4 minus negative 5 squared plus, what is it, 7 minus 3? 7 minus 3 squared gives us 17. All right, now 17 doesn't split, not a perfect square anyway. But remember, we're just trying to compare them, so we wouldn't have to simplify it anyway. LU would be big square root. We are 0 minus negative 4 squared plus 8 minus 7 squared. All right, I do that one in my head. That one does also give us square root 17. As we keep going here, US is going to be big square root negative 1 minus 0 squared plus 4 minus 8 squared. Again, square root 17. And PS is going to be negative 1 minus negative 5 squared plus 4 minus 3 squared. And that is also going to give us square root of 17. Okay, so if you can prove that you have a quadrilateral with all four sides congruent, you have yourself a rhombus. So PLUS is a rhombus because it is a quadrilateral with all four sides congruent. Okay, so if you can prove that your quadrilateral has all four sides congruent, you've got yourself a rhombus. All right, so now what's the difference between a rhombus and a square? Well, a square is basically a rhombus with right angles. Well, how do you prove that you have right angles? You got to do your slopes. Okay, so a square is basically a rhombus with right angles. So I'm going to pick two sides that are next to each other here. I'm going to do the slope of PL and PS. All right. So as I do those slopes, how do I get from P to L? I'm up 1, 2, 3, 4, and over 1. So 4 over 1, which is just 4. Okay. And then for PS, I am up 1 and over 1, 2, 3, 4. 1/4. Now, people get confused because they go, well, those are reciprocals of each other. Those are right angles. But remember, they're both positive. So they are just reciprocals. They are not negative reciprocals. Okay? So it's not a right angle. So PLUS is not a square because there are no negative reciprocal slopes forming right angles. Okay? So if there were negative reciprocal slopes, we'd have right angles, but since there are no negative reciprocal slopes, they're not forming any right angles. So therefore, we do not have a square. Okay? As we move on to our next one, example 3, in the coordinate plane of vertices, the vertices of triangle ROP are as follows. Prove that triangle ROP is an isosceles right triangle. So what I'd like everybody to do is pause the video to prove that this is an isosceles right triangle. So think of it as two separate pieces. You have to do slopes for the right part, and you have to do distance formulas for the isosceles part. So you can see what I did here. Everything I did in red is for my isosceles piece. So I did my 3 distances. I got squared, 20 squared, 20 squared, 40. So then I wrote a sentence, triangle ROP is isosceles because two sides have congruent distances. Then I did my 3 slopes, and I found out that RO and OP, 1/2 and -2/1, were negative reciprocals. So triangle ROP is an isosceles right triangle because it's an isosceles triangle with negative reciprocal slopes forming a right angle. So remember, when you prove something, such as I did isosceles, and then I want to prove something else, I want to carry down what I proved earlier. So since I proved it was isosceles first, I wanted to make sure I wrote because it is an isosceles triangle, and then proved why it was right. Okay, so once you prove something in a sentence, you want to make sure you carry that fact down in any additional sentences as it goes on. So now this has a continuation here. State the coordinates of point E such that quadrilateral ROPE is a square. So they want us to go ROPE would be a square, so we know E's got to end up somewhere around here. Okay, so if you think about it, squares have opposite sides parallel, opposite sides congruent. So we know PE is going to be opposite RO. So if OR or RO had a slope of up 2 over 4, we're going to go up 2 over 1, 2, 3, 4 to find point E. All right, and it might be a good idea always to connect it here just to make sure if you take a look at it, does it actually look like a square? Yeah, it does. And it looks like the one side of that triangle really becomes a diagonal of that square now. So now what's the coordinates of that point? Well, it was -2, 1, 2, 3, 4. So the coordinates were -2, -4. Okay. So if you think about it, it wants us to prove that it's a square. Well, what is a square? A square is a rhombus with a right angle. So if we think about it, how do we just prove that something was a rhombus? We did our 4 distances. Well, nice part is here. RO is already done. That was the square root of 20. OP is already done. That was the square root of 20. So now we just have to do the distance formula for PE and then for RE. Okay, our 2 new sides that we didn't have before. So if we do the distance there for PE, it's going to be -2 minus -4 squared plus -4 minus 0 squared. That is also going to give us the square root of 20. And then for, oops, sorry, that actually, my fault. That actually is our RE distance. Okay, sorry, I found that one in the wrong order. So then for PE, it would be big square root. We are -2 minus -6 squared plus -4 minus -6 squared, which is also going to give us the square root of 20. So what have we proved so far? So we've proved ROPE is a rhombus because it is, or it has, I should say, it has four congruent sides. So now what do we have left to show? Well, we have to pick that there are two adjacent sides that form a right angle. So what I'm going to do is I'm going to pick RO and OP to find my slopes. So if I can find the slopes of RO and OP and show that they are negative reciprocals of each other, I will have myself a square. So the slope of OR is up 2 over 4. So 2 over 4, which is 1/2. And then OP is down 4 over 2. So that's -4 over 2, which is -2. So now we have enough information to show that this is a square. So ROPE is a square because now, again, we proved it's a rhombus, so we need to mention the rhombus in our explanation. So is a square because it is a rhombus with, get myself some more space here, with two sides having negative reciprocal slopes forming a right angle. Okay, so once we do that, once we prove it's a rhombus, and we prove that it's got a right angle, it becomes a square. So this is a pretty extensive proof because it works with all the triangle stuff, asks you to find an extra point and then go to probably the most challenging one, which is a square. But if you can do this one, then you can basically do any coordinate proof that would show up.